Okay, so dual vector space. We will see what this is. Given a vector space over a field K, its dual or conjugate vector space, which we will denote by V star, is the vector space of all linear maps from V to K. So V star, which we also denote using this notation, homomorphisms or linear maps from V to K. So these are just linear maps from V to K. I have to tell you the vector space operations on this set. So what are they? Addition. So if I have, let's say, two elements in this stack, I have to tell you how to add them up. So the sum of this should be another element in this stack. In other words, it should be another linear map. So this should be a linear map from V to K. Therefore, I have to tell you what is the image of this element on a vector. Well, of course, there is an obvious way to define this, right? I just fit this vector in F and in G, and then add the results, right? So I can define addition like this, and scalar multiplication. Scalar multiplication. So if you give me a lambda times F star, so this should be a linear map from V to K, and I have to tell you what the image of this element on the vector. So what can be the image of this? I can just make it to be just lambda and F star. F star of is a scalar K, and you just multiply it with lambda. With these operations, this V star becomes a vector space. So it's a vector space. These operations. Mesela örnekler yapalım. Of course, there are some details that why this this operation is the vector space. You have to prove several things. First of all, this is an abelian group operation, right? F plus G is equal to G plus F. There is the zero element. For example, what should be the zero element? Zero map, right? It should take everything to the zero map. So zero element of this vector space, let me call it zero bar, should be, so this is a map, should be a map from V to K, and it should satisfy the following. If you add it to any map, it shouldn't change, right? Because it's the identity element. Therefore, it is wise to define is the zero map, right? Sends everything to zero map, to zero element of the field, right? So this is the zero element of this vector space. Okay, and then there are other distribution laws and so on, right? Yeah. Okay, so I'll leave the sequence as an exercise. Okay. Now let's see some examples. K is the field, R field, base field. But K is always a vector field over K, of course. Right? K is also a vector space over itself. Değil mi? Bütün şartları sağlıyor. Any field is a vector space over itself. So this is a vector space over B, and this is a vector space over B. K. I'm sorry. Both of them are vector spaces over the field K. Let's see some examples. Example 1. So they need to be R2 and F star is the following. So vector space over the field K, which is in this case R itself. So two elements are just maps from R2 to R. So F star, for example, a map from R2 into R. It should be, of course, a linear map. X, comma, Y. Right? R2 are just pairs of real numbers like this. Can you tell me a linear map? An example of a linear map from R2 to R. X plus Y, for example, which is a linear map. So this is this is an element of B star, right? It's a dual element. It sends vectors to scalars. And G star, another one. For example, is simply one. U star of X, comma, Y, let's say just 2X. Okay. These are X star and U star are created linear maps. So S star and G star are actually elements of V star. Tamam mı? Şu lineerde ne? Note H star X, Y, let's say X minus Y plus 1. This is the map from R2 to R, but it is not linear, right? So it is not linear. It's not linear. And thus, H star is not in V star. Neden linear değil? Hemen söyleyebilir misiniz? Why this is not linear? If it was linear, it should send 0 to 0, right? If you put X equals 0 by 0, you get 1, not 0. Therefore, it's not a linear map. Like a linear map should send the 0 vector
to the zero vector. But in this case, 0 is mapped to 1, which is not the zero vector of the vector space R. Okay. Yani vektör üzerinizden ground field'a giden lineer map'ler, dual vektörler onlar. Dual map'ler. Onu söylemedim. Bu dual uzay elemanlarına, yani bu F star, G starlara da dual vektörler deniyor. Mesela bir örnek daha. Ya da şöyle söyleyeyim orada. Element of the stars are called dual vectors. Second example. Okay. Let me give the vector space of polynomials of polynomials with real coefficients. With real coefficients of degree at most 2. Okay. So here is this digit. Polynomials, real polynomials of degree at most 2. So they have objects like this: a plus bx plus 2x squared, right? A and c are just real numbers. I would like to define a map from B to R. Okay. For example, it's called F star from B to R. And now you can, of course, define, many maps. Can you give me an example of a linear map? So P is mapped to A plus. Okay. So your friend says this. A dx plus 2. Just send it to some of its coefficients. We may also think of it this way, like if this is px, this is just p of 1, right? Evaluation map. You just evaluate the polynomial at 1, right? You can do this. Efendim? Bir öğrenme tekniği. Tabii ki öyle. That's always a linear map. Another one, you can evaluate not only at 1 but any other element also. So, hangisi mantıman değil? F star mı? Zaten beklememen lazım. Why is that? Because you see, this is your whole vector space and this is just R. This is possibly has dimension, in this case it has dimension 3 to dimension 1. It shouldn't be 1 to 1, right? Another linear map, for example, this one. When you give the polynomial, evaluate it any number you want. for example, evaluated part. Okay? This is also a linear map. So this is a real number, right? You evaluate that polynomial at 5. For example, g star of 2 plus 3x minus 4x squared. What is this? You have to compute this polynomial at 5. So this is just 2 plus 3 times 5 minus 4 times 5 squared. So what is this? Kaç? Bilmiyorum. Burası 100 değil mi? Eksi 80 x. Tamam. Tamam mı? Can you check that this is a linear map? So, I mean, if you think that this is difficult, tell me. I'll do it. Otherwise, I'll just continue. Right. This is a linear map. Another one from V to R. For example, take a polynomial and send it to the following. Take its derivative and compute it at 3. This is also a linear map, right? Bunu gösterebilirsiniz, değil mi? I'm skipping the details, but this is also a linear map, right? So what you will do, H star F plus G, P plus Q is what? This is just P X plus 2X. You have to take derivative and compute it. But from calculus, we know that derivative of a sum is just sum of the derivatives, right? This is just P prime and T prime X, and compute it at 3, and this is just T prime 3 plus Q prime 3. But this thing is just H of P, and this is H star of Q. So H star of P plus Q is just H star P plus H star Q. Okay. So you see, actually, these linear maps, I mean, dual vectors are interesting objects, right? Differentiation is there. Of course, integration is also a linear map. Another one. Okay. Okay. So let's take this. You give me a polynomial. What can I do? I can do the following. Integrate from 0 to 1. Yes. This is also a linear map, right? Integration. P plus Q olsa, P plus Q'nun integrali, P'nin integrali artı Q'nun integrali. P plus Q, okay, Px plus Qx. What is this? By definition, this is just 0 to 1. Px plus Qx dx. But again, from calculus, you know that this integral can be written like this. And that is just this is just K star of x, and then this is just K star of x. Therefore, K star is linear. Of course, you have to show this also. But this is just I can always take constants outside the integral. Lambda times k squared dx. So K is a linear map. So these are all examples of linear transformations from V to R or dual vectors. Peki. Well, when you give me a vector space, we constructed its dual, right? Namely, homomorphisms from V to K. This is the vector space, this is the vector space. What we will do is the following. If you give me a basis for this, I will obtain a canonical basis for this one. Using this basis, I will obtain a basis for this. Okay. Of course, this vector space has many bases, but if you give me one for V, then I can obtain a canonical basis for V star using this one. If you give me another basis, then I'll find another basis. And we will see that if V is finite dimensional, then this basis and this basis have the same number of elements. Therefore, these are both of the same dimension. Therefore, they are actually isomorphic vector spaces. Because in a finite dimensional vector space, if its dimension is k, we know that, right? If dimension of is k, then it is isomorphic to kn. And in this case, if this says dimension n, this will have dimension n. Therefore, they will be both isomorphic to kn. So they will be isomorphic. But again, there will be no canonic isomorphism between a vector space and its dual. However, they are isomorphic. So, how to construct a dual basis? Okay, now, given a basis data of a finite dimensional vector space, V over a field K. Here, it's very important that it is finite dimensional. If it is not finite dimensional, then conclusion is not correct. Okay, we will also see that. Given a vector space or a basis of a vector finite dimensional vector space V over field K, we can construct the basis vector star for the dual space, star. Şöyle, şimdi suppose V has the spaces E1, E2, En.
finite dimensional vector space. Right? So this is the basis. Of the. Now I will construct a basis for V star, so E1 star, E2 star, En star, basis for V star. I have to tell you what are these elements. Now, these elements are defined as follows. So I have to tell you what these are. E1 star. What is E1 star? E1 star must be a linear map from D into R, right? So E into 2. It should be a linear map. Right? These are all linear maps. This is a vector space with this basis. Therefore, to define a linear map, it is enough to define this map on this basis element. And if I tell you what the values of this gadget on this basis elements, then I am done. Değil mi? Bir lineer map bir bazdaki görüntülerini söylediğiniz sürece tanımlanmış olur. Bu baz vektörü şuraya götürecek, şunu şuraya götürecek, bunu buraya götürecek. Sadece baz vektörlerinde ne yaptığını söylerseniz yeterli. Lineer algebranın yani gücü bu. Her şeyi değil mi? Baz vektörlerinden ifade edebiliyorsunuz. Baz vektörlerindeki görüntüleri biliyorsan geri kalan her vektör nereye gittiğini bilir. Neden? Çünkü her vektör baz vektörleri cinsinden lineer olarak ifade edilir. Memlerde lineer olduğu için o lineer bağlantıyı korurlar. O yüzden de diğer bütün vektörlerin şeyi bekliyoruz. So I have to tell you what the image of basis elements under this map. And it's very easy. E1 star will map to V1 to 1 and send all the other elements E2, E3, and all others to 0. So E1 star will map E1 to 1, E2 to 0, E3 to 0, E4 to 0, and so on. What about E2 star? E2 star will send second base element to 1 and all others to 0. So this is so if I write here J, okay, so this is 1 and E2 star Ej is 0 if J is different than 2. Okay. And actually write it this way. Şöyle diyoruz. Theoretical delta IJ bu notation'ı biliyorsunuz değil mi? But this means what? This is 0, so 1 is I is J and 0 is I is different than J. So the way we may define these new elements can be, okay, we may define this way. EI star evaluated on EJ on this basis element is just theoretical delta IJ. So if they are the same, it takes the value 1. Otherwise, it takes the value 0. Okay. Okay, now clearly these are linear maps because they are defined on basis elements. Once they are defined on the basis elements, then we can extend them linearly to all vector spaces. to all vector space and okay. Let's do as example. Şimdi, bu beta star'ın ne olduğunu söyledik. Ben şunu göstereceğim. Beta star'ın bir baz olduğunu söyleyeceğiz. Ona işte dual baz diyeceğiz ama onu yapmadan önce bir tane örnek yapmak istiyorum. Soruna cevap vermedim ben. Değil mi? Nasıl olmuştu?
Yani bu beta bazın tanımlama şekli.
Evet, tüm vektör uzayları için. Evet. Finite dimension. Infinite dimension'larda işler değişik. Doğru biz zaten o zaman. Söyleyeceğim şey doğru olacak. Artı olsun. And so this, let's say E1, 1, 0, and include 1, minus 1. Like this is the basis for R2. Like I have two vectors, and they are linearly independent. One of them is not a multiple of the other one. Since this is two-dimensional, any linearly independent set containing two elements must be a basis. So this is the basis. You may ask the following: what is E1 star? What is E2 star? So E1 star is a map from R2, right? V into R, and it should stand what? It should stand the first vector to 1, the second vector to 0. Okay? Can you tell me what this is? Then E1 star. Let's say what is the image of this at xy? Well, if I can write xy in this basis, then I am done. But that's not very difficult, right? Now you see x comma y can be written in this basis
X plus y prime.
Minus x minus y, değil mi? Yok, sadece minus y. Özür dilerim. Minus y.
X plus.
Burada x plus y koyarsak olur. Tamam. So, xy, instead of this, I can write this. This is x plus y times E1 minus y times E2. Right? Because x comma y is just x plus y times 1 comma 0 minus y times 1 comma minus 1. So instead of xy, I just write that thing. Now, what is E1 star then? Since this is a linear map, right, it decomposes and we get x plus y times E1 star of E1 minus y times E1 star of E2. Well, E1 star of E1 is just 1, E1 star of E2 is just 0. So this is just x plus 1. So E1 star then is given this with this expression. E1 star of x comma y is just x plus y. Tamam. Sorusu olan var mı?
Yani hocam, maksadımız benimkileri kullanarak adet bulmak. Yani x plus var genel.
Şunu yapmaya çalışıyorum.
bir basis verildiği zaman vektör uzayının ona karşılık dual basis'in dual uzayın bir basis'ini buluyoruz. Onu tanımladık. Dual basis diyorum. O dual basis'in ne olduğunu böyle hani ete kemiğe bürünmüş şekilde bir örneğini yapmak istiyorum sadece. Basis'in buysa 1, 0, 1, eksi 1. Dual basis ne? İki tane lineer map bulmak lazım. İlki bu. E1 star x, y is equal to x plus y. Tamam. Bir de ikincisi bu. What about the second one? So,
Yani bir ve sıfır eşit olmak yani şöyle bir yani o şey yani artık mı? Yani
bir daha söyle hangisi?
İran sıfır İran kurtulan
Evet, evet. Onları böyle tarif ettim bak şurada. When you give me a basis for D, I define a basis for V star. I didn't tell you why this is the basis here. I just gave you the definition of this element. This element will be a linear map so that it will send the first basis element to 1, all others to 0. The second one will send the second basis element to 1, all others to 0. So they are defined this way. That's why this is called the dual basis of this, and we use the notation beta star because they are closely related, right? I am using this one to define, I am using this one to define.
ama öyle tanımladığımızda her zaman dual space.
Dual space'in ne olduğunu zaten her zaman biliyoruz. Burada derdim şu, dual space'e bazı biliyoruz. Ama bir vektör üzerinde dünya kadar bazı var. Dual uzay durumunda şöyle bir hoş bir şey var. Bu uzayın, orijinal uzayın bir bazını biliyorsam o baz bana dual uzayın kanonik bir bazını veriyor. Buna karşılık değer bir bazını. Ona da dual baz diyoruz ve bu şekilde tarif ediyoruz. Yani şunu söylesem bu tanım her vektör uzay için geçerli mi? Evet. Her sorunlu boyutlu vektör uzay için bunu yapabilir. Bana bir baz verildiğinde onun dual bazını verebilirim. Bu şekilde tanımlıyorum ve bir örnekte de gösteriyorum.
Ama şu dual bazı sarılarken hem birlikte var diyor.
Evet. Ama bu değil mi? Çok mantıklı değil mi? Ne istiyorum? What I ask a linear map from D to ground field. And for each basis element, I want a linear map. So for the first basis element, my linear map does the following. It will send this basis element to 1, and the rest will be sent to 0. The second element will send the second basis vector to 1 and send all others to 0. Okay? Bilemiyorum. Yani senin aklından geçen şeyi görmüyor değil mi için? O yüzden bir şey demiyorum. Anlayacağım şekilde formüle edersen cevap veririm ama sessiz kalacağım bu durumda. Okay, let's look at the other one. So E2 star, x var. Var. E2 star, 0 x, y. Nasıl yazdık onu? Neredeydi? X C1 minus y times E2, right? Again, since this will be a linear map, this is E2 star target. X plus y times E2 star or E1 minus y times E2 star of E2. But this time, this is 0 and this is 1. Therefore, this is just minus 1. So my second element of the dual basis maps the element x comma y of my vector space to minus 5. Tamam mı? Anlaştık mı? Baz verdiğimizde dual bazı yazabiliyoruz. Hayır, dual bazımız E1 star ile E2 star. E1 star, E2 star. Dual elements are two linear maps. Yani x artı y dediği zaman x artı y bir map değil. X virgül y'yi x artı y'ye götüren map dersen tamam. Ama x artı y dersen o bir anlamı yok. Tamam mı? Sorusu olan var mı? Teoremimizde so here I assume that they are finite dimensional under this assumption. So if E1 up to En is a basis for the then beta star to E1 star, E1 star is the basis for this star. In particular, dimension of this star is the same as dimension of B. This is the picture. But as I said, this is true only if B is finite dimensional. Let me write with a diagram. If dimension of B is infinite, for example, the space of all polynomials with real coefficients, okay? It's an infinite dimensional vector space. Its dual is more than itself. It's something even larger. Its dimension is bigger. It's also infinite dimensional, but bigger infinite. Okay? Yani infinite bir tane yok değil mi? Onu gördünüz. 111'de. Bir sürü var. Then this star is not homomorphic. But in this case, they are of the same dimension. Zamanın var mı? Kıpırdanmaya başladığınıza göre yok. Okay, so I'll continue next time.